Hello everyone, my name is Asasi Prisla, a first year computer engineering student at Ghana Communication Technology University, GCTU, and today I am here to present to you my a sketch of an ambulance siren system, and then we move to the code. Okay, so this sketch simulates a basic ambulance alert system using non-blocking logic, so the microcontroller remains responsive. The sketch controls two LED pins, a changing siren tone using the buzzer pin, a push button to toggle user activation, and then serial messages to guide the user to know what is happening inside the code. We set the buzzer pin to 9, the red LED to 3, the blue LED to 4, and the push button to 2. Now the constant in front of the buzzer pin, red LED, and others keeps them fixed and easy to adjust. The siren state, which has been set to false, tracks if the system is on or off. The last button state, which has been set to high, is used for debouncing to detect button presses accurately. The unsigned long previous millis is equal to 0 holds the last timestamp to create timed LED and tone changes. The interval, which has been set to 300, also determines the duration between flashing LEDs. The toggle LED flips between the blue LED and red LED back and forth. So now we move to our setup function. The void setup function runs once when the Arduino code boots up. The pin mode buzzer pin is an output part, so we set it to output, same as the red LED and the blue LED. They are all output systems. The pin mode, the push button, is an input system, and to prevent using unnecessary resistors, I use the input pull-up to serve as a resistor in the setup that I'll be showing. The serial begin 9600 is the baud number for the serial, which is used to display messages inside the serial monitor. So when we start our code, you see it will print "Welcome to the ambulance siren stimulation," and then next it will press the button to activate the siren. So after the user presses the button, it activates the siren till the user decides to stop it by pressing the button again. The void loop function runs indefinitely till the user decides to stop running the code. So in the void loop function, we have bool current state is equal to digital read push button. This detects a button press by comparing the current and previous states. So if the previous state was off and you press it, the bool current button state reads it and detects it, so it turns on the system. The siren state toggles between true and false if last button is same as high and current button state is the same as low. The siren state is not equal to the previous siren state. The delay 200 years to prevent the bouncing of the push button. So if the push button is pressed, it prevents multiple counts of one press. The serial print ln it displays in the serial monitor siren activated when the push button is pressed once, and then displays again siren deactivated when the push button is pressed again. The last button state is equal to current button state. Update the last state for the next loop comparison. So now we move to the siren activation with non-blocking timing. If the siren state and current millis minus previous millis is greater than or equal to the interval, the previous millis is equal to the current millisecond, and here millis is used to stand for milliseconds. So we toggle the LED. The millis returns the number of milliseconds since boot up. This creates a timed toggle effect mimicking flashing lights. Now we move to the digital read red LED high and low, then digital read blue LED high and low. So this set of code is for alternates which LED is on and changes the buzzer frequency to stimulate a siren. So we have the tone buzzer pin toggle LED between 100 and 900. So if the red LED is on, we notice our frequency will be at 100 or pitch for the buzzer. And then when our blue LED is on, we notice the frequency will change to 900. We will be looking at all that in the setup, which I'll be moving to very soon. Now this set of code here, siren is off, is to turn off, like to prevent the system from operating when nothing has been done. It ensures everything is off when the